Hello everyone, today I would like to show you how to use the second shift theorem for the inverse Laplace transform. Okay, first of all, for the second shift theorems, let me tell you what is the formula or the theorems of the second shift theorems. Okay, this is the formula that you need to know. Okay, Laplace transform of the ft minus a u t minus a unit step t minus a equal to exponent negative sfs. Okay, so this is the Laplace transform for the f t minus a and then unit step t minus a. So some of the books, they may use the, instead of u, they may use the hash. Is the same, either u t minus a or hash t minus a, also the same. Okay, so this is Laplace transform. What about the inverse Laplace transform? So the inverse Laplace transform is the same for this one. So inverse Laplace transform of the exponent negative as fs, so it's the s domain, it would be equal to this one. So it's the f t minus a u t minus a. Okay, so this is the theorem that you need to know. Okay, now let's look at the example. Okay, example, let's say you have this one, inverse Laplace transform. Okay, inverse Laplace transform of 2 over s minus 3 exponent negative s over s plus 4 exponent negative 3s over s squared. So find the inverse Laplace transform of this expression using the second shift theorems. Okay, and then write the answer in the form of the unit step function. Okay, and slash the graph. So how do you solve this question? So first of all, let's take out the constant. Okay, what is the constant of this? Okay, let's say if you look at the 2 over s, the constant is 2. So you take out the 2 first. And then for 3 exponent negative s over s, so 3 is the constant. And then for the 4 exponent negative 3s over s squared, and then the 4 is a constant. Okay, so which one you need to solve? Okay, this one is easy. This one you need to solve using a second shift theorems, and this one also you can solve using second shift theorems. Okay, for the second order shift theorems, you need to know that you need to make sure that the expression must in the form of the exponent over polynomial. Okay, you need to make sure that in order to use the second shift terms, you need to make sure that the expression is in the form of exponent over polynomial. Okay, if you look at this one, this is not exponent, so you cannot use the second shift theorem. But this and this is the exponent, and this one and this one is the polynomial, so you can use the second order shift theorems. So this is, you have to be careful. You have to make sure that it is the expression of this in the form of the exponent over a polynomial. Okay, to do this, first of all, let's solve this exponent negative s over s. Okay, there are few steps to follow. If you have the module, you can go for the page 1 to 8 to follow the procedure. Else, I can write it here. Okay, the step number 1 is you have to determine the value of a. What is a? Okay, if you refer to this one, actually is referred to exponent negative as over s. Right? So what is the a here? Okay, from here you know that a is equal to 1. Okay, you compare these two. And then the second step, you find the fs. Okay, if you have the exponent negative as over s, so the fs is 1 over s, because it's like this. Right, so this is the fs. Okay, why I say like this? Because if you look at the formula here, okay, exponent as fs. Okay, if you compare with this one, exponent as over s. Okay, so for sure that you know this is the fs. Okay, so your fs is 1 over s. And then the third step is you need to find the ft. The Fourier transform, the inverse transform of the fs, you find the ft, right? So what is the ft? Is 1. Okay, this is we studied before, 1. And then step number 4, change the variable form, change the t to t minus a for the function, ft. So now your ft, you change to ft minus a equal to 1. Okay, step number 5. Evaluate the inverse Laplace transform. So you have to evaluate the inverse Laplace transform of this. Okay, so would be equal to, if you follow the formula, is this one, f t minus a ut minus a. Okay, now is ft minus a, what is the value? Equal to 1. ut minus a, what is the a value? A is 1, so ut minus 1. Okay, now we have done for the f exponent negative s over s. Now let's check for this one, exponent negative 3s over s squared. Okay, so what is the, okay, let's start again. So what is the a? Okay, a from here is exponent negative 3s, so a equal to 3. Okay, step number 2, fs is 1 over s squared. Okay, and then step number 3, what is the ft for the fs given? Okay, you refer to the Laplace transform table, you can find that if you have a 1 over s squared, okay, you still remember t power of n is equal to n factorial s power of s plus 1. N plus 1. So if you have s over s 1 over s squared, means that the t power of t is power of 1. So t here. And then step number 4. So you substitute the substitute the t equal to t minus a. Okay, if this one also the same, the t is t minus a, but a value is 3. Okay, and then step number 5. So inverse Laplace transform of the exponent negative 3s over s squared. Okay, so as this inverse Laplace transform, you have ft minus a, ut minus a. So for ft minus a, you have t minus 3. And then ut minus a is 3, so t minus 3. So this is for the exponent negative 3s over s squared. So you can combine, since you have the two answers here. Okay, and this one. Okay. So the answer for the inverse Laplace transform of this equal to 2. Okay, 2 is a constant. Okay, 1 over s, you obtain 1. Okay, minus, then your answer is unit step 3 ut minus 1. So you have the 3 here, 3 ut minus 1, and then plus 4 t minus 3 ut minus 3. So this is follow the procedure. Follow the procedure to find the answer. What if you don't want? If you want to do the shortcut, also I can show you how to find using the shortcut. Okay. Okay. Let's say. Okay. Okay. Using same formula, same equation or same expression. Okay, we find. Okay, we need to know for the inverse Laplace transform of the exponent negative s over s, what you obtain. Okay, first of all, we do the Laplace transform, inverse Laplace transform of the 1 over s first. Then we consider the exponent negative s. Okay. So we consider this one first. Then so means that we obtain the inverse Laplace transform of 1 over fs, 1 over s first. Then we consider the exponent negative s. Okay. So as we know, inverse Laplace transform of 1 over s equal to 1, right? And then this one is, okay, exponent negative s. As you know, exponent negative s is a shift. So exponent negative s is the 1. The a is 1. So you have the shifting is 1. So, but plus this 1 over s is also 1. So it's 1. For the 1 over s is 1. So you write 1. And then the shifting, exponent negative s is shifting part. Shift for 1, so u t minus 1. Okay, so this for this one, and then second one is this. Similarly, you obtain the 1 over s2 first, then you find for the exponent negative 3s. Okay, so inverse Laplace transform of 1 over s squared you obtain is t, right? So for the inverse Laplace transform of exponent negative 3s over s squared, okay, so you know that this is t, but this is t exponent 3s, negative 3s, so means that it shift for 3 steps. So each of the t will be shift for 3 steps. So 3 minus 3, ut minus 3. So this is the shortcut that you need to know, because second shift theorems, that's why you need to t minus 3, ut minus 3. So at the end, your answer is the same. 2 minus 3 unit step t minus 1 plus 4 t minus 3 ut minus 3. Okay, so from here you need to change to the step function. This is the unit step function, right? then you need to change to the step function. Okay, step function means that, okay, from 0 to 1, what did you obtain? From 1 to 2, what did you obtain? From 3, what is the function? So you need to write in the step function. So how from this unit step function change to the step function? Okay, if you still remember, before that we learned the change the step function to the unit step function, which is in page 125 in your module. We use that formula. Okay, we use that formula. Or I can write it here: G1 plus G2 minus G1 unit step function t minus A1 plus G3 minus G2 unit step t minus A2. Okay, then you compare using this formula. Let's say G1. Okay, G1. If you compare G1, what is your obtain? This is G1. Okay, this one is G1. So G1 is 2. Okay, now G2 minus G1. G2 minus G1, it should be equal to -3. So equal to -3. So G2 will be -3 plus G1. G1 is 2, so you have -1. And then G3 minus G2. Okay, G3 minus G2, you obtain 4t minus 3. So G3 equal to 4t minus 3 plus G2. G2 is -1. So this one will be 4t 12, -12, -1, so -13. Okay, now okay, for this part, A1 is what? A1 is 1. A2 is 3. Alright, so write it in a step function. Okay, so your 2 is from 0 to the t is from 0 to 1, and then for -1 is for 1 to 3, and then you have the 4t minus 13 is for t more than equal to 3. So this is the step function. We change from the unit step function to step function. Okay, how if we have the step function, we can plot the graph. Okay, let's plot the graph. Okay, 0 to 1, you have 2. So 0, this is 1, 2, 3, 0 to 1, you have 2. And then 1 to 3, you have -1. So this is -1. And then more than 3, you have 4t minus 13. So 4t minus 13, how to plot 4t minus 13? So you can write, if t equal to 3, so what you obtain? You substitute the t equal to 3. So 12 minus 13, you obtain -1. So it's still here. Okay, you can substitute a 3. So when t equal to 4, what do you obtain? T equal to 4, so it's a 16 minus 13, you obtain 3. So you have +3 for t equal to 4. You have a 3 here. So it's like this. Okay. Okay, let me show you another example to increase your understanding. Okay, let's say if you have the inverse Laplace transform of the exponent negative 5s 1 plus 2s over s squared. Okay, then find the inverse Laplace transform using the second shift theorems. Okay, as I said before, you can follow the step. So now let's follow the procedure. Step 1, you need to find what is the value of a based on this one. Okay, based on the exponent. So if you have exponent negative 5s, the a is equal to 5. Okay, step 2, write down the function of fs. So what is the fs? Okay, as I told you before, the fs, if you use this formula, okay, exponent negative as fs, so you already have this part, so fs is the remaining part. So fs is 1 plus 2s over s squared. This one actually you can split into 1 over s plus 1 over 2 over 2s over s squared, or you can write it to 2 over s. Okay, so step number 3, find the ft. So ft for this one, for 1 over s is equal to, oh sorry, I think this was s squared. Okay, 1 over s squared is equal to t. Okay, based on the table of Laplace transform, 1 over s squared is t, and then plus with 2, and then 1 over s is 1, so it's t plus 2. Then step number 4, then change the t to t minus a. So you have f t minus a equal to, so this one is t minus a is 5 plus 2, so t minus 3. And then step number 5, find the inverse Laplace transform. Okay, so the inverse Laplace transform f t minus a u t minus a. Okay, f t minus a you obtain is t minus 3. Then u t minus a, and a is 5, u t minus 5. So please bear in mind that this don't mix up. Okay, this u t minus a, the a is follow the first one. If f t minus a, because we already do the substitute the a before, so is you obtain t minus 3. And then you'll come okay, your final answer is this one. Then you have to change it to the step function. From here you change to the step function. Okay, the step function is g1 plus g2 minus g1 u t minus a1, right? Okay, if you, what is g1 here? Based on this answer, g1 seems like 0. You don't have any g1, so g1 0. Then g2 minus g1 is equal to t minus 3. Okay, it's based on this one, t minus 3. And then okay, now you have the g2 equal to t minus 3 minus g1 0, so it's still t minus 3. Okay, and then the a, what is the a value? What is the a value? A is equal to 5. Okay, a is equal to 5. So when you write into a step function, it's 0, okay, and then the t from 0 to 5. Then you have t minus 3 for t more than 5. Okay, then you can plot a graph. If 0 to 5, let's say this is 5, 0 to 5, you can obtain 0. And then after more than 5 is t minus 3. Okay, t minus 3. Let's say if t equal to 5. So t minus 3 is 5 minus 3 equal to 2. So at t equal to 5, you have the 2 here. And then t equal to 6. So 6 minus 3 equal to 3. 6. This is 3. 3. Okay. So now you know how to use the second shift theorems, and then change it to the you use the second shift theorem to find the inverse Laplace transform, and then from the unit step function you change to a step function and then plot a graph. Okay, that's all, and for the unit step function of the inverse Laplace transform, and thank you for watching.